In the last discussion, we already discussed the motion of charged particle under the influence of electric field, magnetic field. Now we have here applied simultaneously the electric field and magnetic field, and the direction of that electric field and magnetic field are perpendicular to each other. Therefore, we have said that the motion of charged particle in cross the electromagnetic field. So here we have to show the electric field is along y-axis and magnetic field of induction V is along z-axis. Vector V shows the direction of the velocity of that charged particle. Then here the force acting on that charged particle is F is equal to Q into E plus Q dot V cross B. So Q into E is nothing but force developed by electric field, and Q dot V cross B is a force developed by the magnetic field. So we know very well mass into acceleration is nothing but the force. So M into dV by dt is equal to Q dot E plus Q into V cross B. Call this equation number 1. Solution of this equation is like V is equal to V dash plus E cross B upon B square. Call this equation 2nd. This is the differential equation. Number 1 equation is our differential equation. Solution finding by mathematically, we have to get that solution of this equation is V is equal to V dash plus E cross B upon B square. Call this 2nd. So instead of E cross B upon B square, we have to put one of the constants, say vector Vd. So we have to write V is equal to V dash plus Vd. So where Vd is equal to E cross B upon B square is nothing but our drift velocity. So if we have to put this value of V in equation number 1, we have to get M dV dash by dt plus M d by dt of E cross B upon B square is equal to Q into E plus Q dot V dash plus E cross B upon B square cross B. Call this equation number 3. Here E and B are the constant. As E and B are constant, derivative of constant is going to be 0. So we have to write d by dt is equal to E cross B upon B square is equal to dVd by dt is equal to 0. That is equation number 4, where Vd is constant, that is E cross B upon B square is constant because E and B are constant. So equation 4 suggests Vd is constant. Vd is nothing but our drift velocity. So we have to say this equation 3 terms to M dV dash by dt is equal to Qe plus Q dot V dash cross B plus Q upon B square E cross B cross B. Call this equation 5. Now we have to solve this E cross B into B square. By using the identity, we can write this as E cross B into cross B is equal to E dot B into B is equal to B dot B into E. But E and B are here perpendicular to each other. Electric field is along y-axis, magnetic field is along z-axis. So E dot B is nothing but EB cos theta. So here angle is 90. So EB cos 90, that means going to be 0. So E dot B is equal to 0. And similarly B dot B is equal to B square. We have to use this here. So E cross B into cross B is equal to minus B square into E. So we have to put this value of this one in equation number 5. So M dV dash by dt is equal to Q into E plus Q dot V cross B in minus QE. Cancelling these two terms, only remaining terms is M dV dash by dt is equal to Q into V cross B. Call this equation 6. And this is the similar equation when charge force under the influence of only magnetic field. That is, when only magnetic field is applied, at that time same equation is to be obtained when electric field and magnetic field are applied cross to each other, that is perpendicular to each other. Now we are interested to find out what is the trajectory is traced out by that charged particle which is under the influence of cross electric and magnetic field. We already assumed that the magnetic field is along z-axis, electric field is along y-axis. So the component of magnetic field along z-axis is nothing but k cap bz, and a component of the electric field along y-axis is j cap ey. So V is equal to I cap Vx plus j cap Vy plus k cap Vz. Using this in equation number 1, we have to get m d by dt. Instead of v, we have to write this equation, this value of v here. I cap Vx plus j cap Vy plus k cap Vz is equal to j qey plus q into v cross b. V means your I cap Vx plus j cap Vy plus k cap Vz cross k cap Bz. So solving this bracket, we have to get I cap m dvx by dt plus j cap m dvy by dt plus k cap m dvz by dt, j qey minus j. Minus j means here I cross k is nothing but minus j q vx bz. Then j cross k is nothing but I, so I into q vy bz. So comparing coefficient of I, j, k of both sides, we have to get m dvx by dt is nothing but, what is I cap here? Q vy bz. So q vy bz, or you may write this dvx by dt is equal to q by m bz into m, call this equation 7. So m into dvy by dt, the coefficient of this j is here qey minus q vx bz. Transferring m to this side, so we have to get dvy by dt is equal to qey upon m minus q bz upon m into vx, call this equation number 8. And m into dvz by dt is equal to, no coefficient of k cap is here, that value is going to be 0. So we have to get dvz by dt is equal to 0, call this equation 9. Let we have to put the qbz upon m is equal to omega. This is one of the constant. So we have to say dvx by dt is equal to omega vy. So we could write this omega vy, call this equation 10. Again dvy by dt is equal to qey by m as it is. So qbz upon m, instead of it we have to put value omega minus omega into vx, call this equation 11. Differentiating equation 11, we have to get d2 vy by dt square is equal to, this term is going to 0, minus omega into dvx by dt. So dvx by dt is already known from equation 10. So we have to use this value in this equation. We have to get d2 vy by dt square is equal to minus omega square vy. So we have to transfer this to this side, d2 vy by dt square plus omega square vy is equal to 0, call this equation number 12. So we get equation 12, which is similar to that of the simple harmonic motion, and solution of that equation is vy is equal to a sin omega t, call this 13. Use this 13 in equation 10, we have to get dvx by dt is equal to omega a sin omega t. So dvx is equal to omega a sin omega t dt. Integrating this term, vx is equal to minus omega a cos of omega t upon omega plus c1, where c1 is constant of integration. So vx is equal to minus a cos of omega t plus c1, because omega get cancelled, where c1 is constant of integration. We have to consider the initial conditions. So at t is equal to 0, velocity along x-axis is 0. Putting this value here, we have to get c1 is equal to a. Putting this value of constant of integration c1 in this equation, we have to get vx is equal to minus a cos of omega t plus a, call this equation 14. So vx is equal to a taking common, 1 minus cos of omega t, call this equation 15. From equation 13, we have to get vy is equal to a sin omega t. Differentiate this with respect to t. We have to get dvy by dt is equal to omega a cos of omega t, all this 16. Now we have to use equation 15 and 16 in equation number 11. At that time we have to get omega a cos of omega t is equal to QEY by m minus omega a into bracket 1 minus cos omega t. We have to solve this bracket, so we have to get omega a cos omega t QEY by m minus omega a minus minus plus omega a cos of omega t. So QEY by m is equal to omega a, because these two terms getting cancelled. So a is equal to QEY by m omega. So we know very well omega is nothing but QBZ upon m. So we have to put that value here. We have to get a is equal to m upon QBZ into QEY by m, because putting the value of omega, those terms is cancelled, m get cancelled, QQ is get cancelled. Only a is equal to EY by BZ. So Vy is nothing but, now putting this value of a in this equation 13, we have to get Vy is equal to EY upon BZ sin of omega t cos 17. And similarly we have to put this value of a in equation number say 15. We have to get Vx is equal to Ey upon Vz 1 minus cos of omega t, call this equation number 18. Now we have to use the definition of velocity along x-axis and velocity along y-axis. So Vx is equal to dx by dt and Vy is nothing but dy by dt. So putting this value in equation of Vx, we have to get dx by dt is equal to Ey upon Vz in bracket 1 minus cos omega t, cos this equation 19. And similarly value of Vy, that is dy by dt is equal to Ey upon Vz sin of omega t, call this equation 20. From equation 19 we have to write dx is equal to Ey upon Vz 1 minus cos of omega t into dt. Integrating this equation we have to get x is equal to Ey upon Vz, integration of 1 is a t, and integration of cos omega t is nothing but sin omega t upon omega. So plus c2, that is constant of integration. So to find out the value of constant of integration, we have to consider the initial condition at t is equal to 0, x is equal to 0, the displacement along x-axis is 0. So we have to put this value here, we have to get c2 is equal to 0. Putting this value of c2 again in this equation, we have to get x is equal to Ey upon Vz, t minus sin omega t upon omega. So x is equal to Ey upon Vz, omega t minus sin omega t upon omega. So take omega outside, so we have to get x is equal to Ey upon Vz into omega into bracket omega t minus sin omega t, cause this equation 21. So from equation 20 we have dy by dt, that is, now we are right, dy is equal to Ey by Vz is equal into sin of omega t into dt. So here in equation 20 we have write this like this one. So integrating that equation we have to get y is equal to minus Ey upon Vz cos of omega t upon omega plus c3. Again c3 here, constant of integration. We have to solve that value of constant of integration by considering the initial value, that is at t is equal to 0, displacement of particle along y-axis is 0. So putting this here, we have to get c3 is equal to Ey upon Vz omega. So put the value of c3 in this equation, we have to get y is equal to minus Ey upon Vz cos of omega t upon omega plus Ey upon Vz into omega. Take the common Ey upon Vz omega, then term remaining is 1 minus cos of omega t. So y is equal to Ey upon omega Vz 1 minus cos omega t, cos this equation 22. So from equation 9 we have Vz is equal to, say, Voz is equal to constant. So Vz is nothing but displacement along, so velocity along z axis. So dz by dt is equal to Voz. So z is equal to Voz into t plus z0. By integrating this equation we have to get z is equal to Voz plus z0, where z0 is again constant. So to get the value of constant we have to take the initial condition, t is equal to 0, at that time z is equal to 0. Putting this we have to get z0 is equal to 0. So putting this value here, we have to get z is equal to Voz into t, call this equation 23. So we have to get the displacement along x-axis by using equation 21. We have to get the displacement along y-axis by using equation 22, and we have to get the displacement of charged particle along z-axis by using equation 23. By considering 21, 22 and 23, it decides the path of that charged particle, and we have to see that that path is cycloid path, so which is diagrammatically shown cycloid path along x-axis. So